Hi, I'm Line Clemmensen. I'm a professor at DTU Compute, and I'm also the Chief Scientific Officer of Tetatet AI, and also involved in the startup journey of soil health. And my entrepreneurial journal actually started with me presenting my research at an online webinar. So in that spirit, I will more or less start with my research and then end up with the startup companies that I'm involved with. All right, so just it's a lot of collaborations doing research. So I have a lot of collaborators within the psychiatry, both psychologists and psychiatrists, and then of course also my lab at DTU Compute. And my research is a little bit on looking at videos, so computer vision parts, speech, but also wearable devices, and looking into these different kind of signals. What can we actually use them for? How can we help a psychiatry which is undermanned and which in many cases also could do new therapies, new and more preventative methods within psychiatry, because we have digital solutions and AI to support that. So for example, when you have people with schizophrenia or other diseases, when they have a relapse, you can treat that, but you don't get back to the same baseline. So it gets sort of worse and worse. So you really want to detect these kind of relapses early and treat them before they are occurring. And yes, so it's really important with this kind of maybe not as visible monitoring of what are the triggers and events that might happen where we can go set in. All right. Some of the research I've done is on computer vision, and this is really looking at psychological behavioral analysis. So these CIB, coding interactive behavior items, those are old psychology constructs from Ruth Feldman, 1998. And so we've looked at that, and then we've said, okay, what do we have of AI models out on the left that can actually get us somewhere close to this? And then we have put a symbolic AI, so basically rule-based, down on this and looked at, okay, how can we make estimates of positive effect, negative emotionality, anxiety, etc. And for a lot of these constructs, we actually found, without retraining any machine learning, that we can use these AI tools and get an agreement which is what we would say that experts are agreeing if they're above 80% on this scale. And so we can do that with negative emotionality, activation, arousal, anxiety, to some extent attention and positive affect as well. Gaze and vocalization, a little bit more difficult. I haven't used speech here, whereas the human coders actually have access to that, so it's only based on the visual cues. So there's a little bit more to do there. And gaze is also something that's fairly difficult when you haven't set up the system in a very formalized way. So what we've done is taken videos of screening situations that were not meant for developing AI tools. So it's really in what we would call in the wild data. All right, so we have this nice agreement, and if we take out the two, gaze and vocalization, we actually have an agreement which is acceptable on these. Right, and this is the behavioral logic, but just to really stress that it's symbolic AI, and we haven't trained a lot. This is one of the challenges in psychiatry, is that usually don't have access to a lot of labeled data. And this is the reason why we didn't include speech in the beginning. So we're dealing with children, videos of children, and diagnosed children. And what we found was that even just detecting when does a person speak and when do they not speak, we had significantly different results based on whether it was a child and it was a child with a diagnosis. These models are usually trained on an adult, normal, usually male population. And so there were some issues in this transfer. So there's definitely some stuff that we think should just be working, but which is actually not working for specific parts of the population. And then we also have done it's a feasibility study with what we call the Wrist Angel. So it's really children with obsessive compulsive disorders. And we want to use a wearable, I mean, it's like a Fitbit or an Apple Watch or something, but it's medically approved. And then monitor them. And we also have some lab exercises where we get them. And we wanted to see if it was possible to, from these physiological signals, see if we can detect OCD events. And what do we want to use that for? Well, part of it is for the treatment, so give it as feedback for the psychiatrist, that usually the therapist will, one of the questions they ask every time is, how much have your obsessions taken part of your daily life over the last week, 2 weeks? And for a child, time is, not something, it's difficult enough for us as adults to answer, okay, how much did it actually take up of the last 2 weeks? And a child will answer something and you have no idea whether this happened 3 months ago or today. So having some kind of a little bit more objective measures could be valuable information. Another thing we would love to do with this is to make a kind of thermometer for at-home exposure therapy. So usually the parents get a piece of paper. Here, go home and do exposure therapy as a homework. And that can be very difficult. And what usually happens is in this OCD cycle that the children recruit the parent in to actually support them, because the immediate relief is from these obsessive that you do the actions, right? And that feels right if you're an empathetic parent. You help your child, but actually you should break that cycle. And so having this kind of thermometer saying, okay, am I giving a suitable amount of stress to the child that they can overcome? It shouldn't be too much, and it should also not be too little, because then we're not really training that we're breaking these cycles. So these are the things that we want to do with this. And these are our results, and it's really, we had 9 patients and 9 control. We have them over 8 weeks, so we have several repeated measured, but there's a lot of variance in this kind of data, so this is one of the things we also learned, we want a lot more individuals, but there is something, like we get a 70% prediction rate, but we also get too many false discoveries. Absolutely, to make this work in practice. So there's still a lot of stuff to work on. I also work with register-based. So there is this specific is on like precision medicine, where we're predicting at discharge from the adult psychiatry the risk of suicide and suicide attempt. And so you might be able to take some additional measures if you know that there is a high risk. And so we did some different models with that, and also looked into some equalized odds, so basically some fairness on, are they performing equal for different sex and age, these models. So I think, and this is mainly to say there's a lot of stuff, a lot of inventions to do in this area, a lot to come for new startups, or just having new ideas. And one of the things we were using for this computer vision things was facial emotion recognition. And here we have just tried out in a research project a lot of different models, looking at, okay, can we do something that's a bit more scalable if we want this in an app rather than taking the largest model? And that is actually possible. There are a few of them that are performing quite well, even though they run faster. We also scaled our videos, and you can see that you actually get a similar accuracy, even scaling down to 32 by 32 or 48 by 48 pixels of, when you have the face, right, in focus. So, and then we also did a bit of, fairness analysis, looking at, is it prediction equal for different demographic? And you can see that there are some issues. It's actually not as bad as we had expected, just to say, but there's a bit like here, sad and neutral, and disgust and angry is slightly different for female and males. In particular, the angry, you have a higher prediction accuracy for males than for females. We also looked at age and different ethnicities, where there are, again, a few things. Asian black on surprise, for example. There is a difference in the same for Asian and versus white. There's a difference in prediction accuracy. But so there is still, stuff that we technically and research-wise should also do, and we need to, of course, use these tools with caution, just to say. All right, and then back to my entrepreneurial journal. So this is Tetatet AI, and so it's basically an app that you can speak to. Okay, so there is a speech-to-text and text-to-speech involved, and then we're using the facial emotion recognition to understand and give feedback. For example, in salary negotiation training, you can go in and do that with a persona, and that could be someone that was similar to your boss, but you could also do it with different personas, understanding, okay, how am I actually training? Maybe you take a course and you actually want to practice a little bit before you go in and ask your boss for a salary increase. So you can do that with our app. And then you get feedback also on what am I conveying. So one thing is their argumentation, but another thing is also, how does it feel to be in that room with you? What are the sentiments in terms of your voice, in terms of all of the cues you're sending with your body and face language? And so we're using some of the research tools that are illustrated in those coding behaviors to give this kind of feedback and train in here. So one of the initial things we did was actually just to go in and train on emotions, something you could, for example, use if you were on the autism spectrum. So instead of having those little spectrograms, you can train with this and then displaying, okay, what does happy look like? Okay, now I actually look happy and I get this kind of immediate feedback from this rather than looking in the mirror and trying to understand that yourself. So that was Tetatet AI, and the CEO, Paula Pecco, I met her at this online webinar, as I explained, and our talks were like completely aligned. Her ideas that she was pitching for competition, and then my research, and then we've been talking since then and founded Tetatet AI last year. We're right now in a sprint with Antler, and took in one more founder, more on the design and marketing space, and then we have Troels, who's been many years in Lundbeck working as a CTO. So we're 4 right now, and we'll see how that sprint goes and where that takes us. So this is quite exciting. Then I also have a collaboration with Nina Glenny, who is doing soil health with us, and we have also a psychiatrist, Jörg Albers, involved with that, and then a CTO as well. And here we're using some of the same technology, as you might see, but we're using it for doing couples therapy online. So instead of, all of these barriers that it is to say, okay, yeah, we want to do something, maybe are those problems really big enough for us to pay that much and to wait 3 months to find someone who has availability for us, etc. And maybe you forget about it. I mean, I'm on husband number 2, so I definitely know how this can go. And here you get it delivered at home in an app. And we're using some of these cues again also to see, okay, when are we, for example, saying that we're fine or that we accept something, but like our body language and our voice is kind of saying the opposite. Maybe this is where we want to ask follow-up questions, just like a therapist. So it becomes this third pair of eyes, just like a therapist would. Yes, and then you can do both individual exercises, working with your own emotional expressions and just where you are, doing relaxation, little breathing exercises, or just other things, and then in this space where you're doing it together. So the app, as it is right now, we just talk to it, but we can set it up in a mode where it's, taking in several people and can give feedback on that as well. So this idea we're pitching for an inner explorer next week. So we haven't founded the company yet. So it's really, pre-seed on this one. And And then just to say, I mean, so I think part of this, you've also realized that I'm like, have a lot of ideas and a lot of research where I think there's a lot of potential in this mental health space. And I really wanted to convey some of all this enthusiasm I have about, that technology can help us in a space where we are experiencing a mental health crisis, and we don't have hands enough to actually support and help us, right? Al Jazeera English did this really nice documentary piece called, where it's like inventing mental health solutions in Denmark. I have like 2 minutes somewhere in the middle, but really I recommended all the other people doing startups and doing things within this are really great. I love in the end you have a patient with schizophrenia and she gets to train talking to her voices at the end, like making it a persona, and really says this is the first thing that really works for her, right? And then she can sort of talk back rather than, okay, what is it actually I'm experiencing? And that has helped her a lot. So I think this is, I recommend it. And also if you're considering doing a startup in this space, so much to do, and please reach out. I think the next startup is also really kind of demonstrating this, that there is a lot of things that we can do to help us out.
Thank you so much, Line. Let's see if we have any questions in the room. Otherwise, there might be some online. Did it spark any questions for you? Otherwise, I'll open the floor. So I was wondering, in terms of the difficulties of detecting what people are doing using cameras and hearing what they're saying, did you look into the sociometric badges from Sandy Pentland's group at MIT?
I haven't looked into the badges, and I think there is a lot of research out there showing that, for instance, from speech you can detect depression, different other things. So research-wise, there is a lot to do. We have not focused so much on speech yet, because a lot of my focus was on these children, and we had that initial, so everything we would do following up on that would be biased by the fact that our initial just detecting when the child was speaking wasn't, equal across our populations, right? Yeah. Of course, you could also see that as an indicator, but nonetheless, we didn't know what that indicator was actually saying. Yeah. It's a little nicer to have, okay, there's a specific, pitch or tone or something which differs. So we've been working a lot on trying to make some of these models more fair before we add in the speech for the children. But for the startups, yes, we can definitely use those speech and some of the things that were derived in other research to monitor the sentiment. Yeah.
Very cool. And then you were looking at actually, we do have a question over here. Let's give it to the audience.
Thank you for exciting lecture. I wonder about the speech recognition. Do you use any semantic analysis at all? I mean, it might as well be whale song that you're talking about here, but do you use also the semantics? Differences in
I think we want to work on this both from, what is being said and how is it being said, right? And some of the interesting part is when the sentiments in those two parts are in opposition. Right? So this is what we were doing. So looking at, okay, what you're saying is neutral or even has a positive sentiment if you just look at the text. But the way you're saying it, has some kind of negativity emotion, whether that's being sad or anxious and this opposition is where it becomes interesting as a therapist, right? This is the kind of like eyes and ears they are using to understand when they're sitting with a person or a couple. Okay, here I need to ask some follow-up questions, right? Okay, how does it make you feel? Or can you elaborate a little bit of this? Can you give some examples? And then we start understanding a little bit, okay, what's actually going on, right?
Do you also pick up the interlocutors, what they say, so it's a response or is it solely the analysis? Do you solely have the data from the target person?
So right now we have mainly in the avatar person, but in the couples therapy, you would also have two individuals, right? And a response. And the response, of course, is also interesting in body language. Like, is one person sitting like this or like this? Or, there is some kind of intercommunication also, right? So, like, are we responding to each other? Are we mimicking each other? These are some of these like synchrony measures that are also relevant to look at once you have couples. We also use that in the psychiatry where we have children and parents in sessions. Yeah.
Cool. I think we got some questions online.
Hi. There's a lot of applause online. There's a lot of clapping hands. I just want to let you know. And then Gustav Hjerting asks, how do you think the EU's IA Act will impact developments in the area of mental health using AI in both positive and negative ways?
Yeah. That's a very good question. In parts, it might slow it down. And I think we need to look a little bit more on purpose. I think the first version was, very like, okay, I set up some frames and some very specific criteria, which, then becomes how do you interpret that, and are those the right criteria? And we've moved a little bit away from that to a little bit more purpose and intention. And I like some of FDA's, like in the US, where there are a lot more, what's the risk? Okay, what's the worst thing that can happen, right? And that will be different from different applications. We can't just say, okay, mental health, everything is dangerous, right? Maybe some things, like the worst thing is that the therapist gets some feedback that isn't accurate, but the therapist is still sitting there and, doesn't have to lean 100% on this. They're using a lot more things. So maybe that's not a high-risk situation, really. So I think we need to think a little bit more like that. And then in those cases, fine, we can do more things and we can be a little bit more innovative. But then where, I haven't suggested anything where we're saying, okay, all the treatment in the psychiatry should be done by AI. And like, no way, right? This is not where I'm coming from at all. But if this was what you wanted to do, that's a lot higher risk. You want to make sure you're not doing harm. And then okay. And I think, for example, emotion detection is one of them, but what does it mean? Doesn't it, that's maybe because we're afraid of surveillance. But what's the purpose of it? Is it, is it a sentiment analysis to give some cues where we're not directly saying, you should not be working here, or where it's like feedback for you as an individual, nobody else sees it. You can take it or leave it as you want, right? Just like you get feedback from an individual at the workplace or a therapist. That's not a ground truth necessarily, right? So I think we need to understand and discuss some of these things a little bit more so we're not so kind of boxed into to criteria that doesn't make sense. I really like to lean towards our food control, also because my father worked in that area for many years and sort of completely revolutionized that. But this is where you have self-control, right? And you talk a lot more about, okay, what's the purpose of the rules? It's not like your sink needs to be in this height and da-da-da. No, it's like, okay, you need to tell me that you have set up a sink where the people working there can wash their hands and so that there aren't bacteria. And then you can say, okay, for my space and in my production, it makes sense and I can say I did that, right? And so I think we need to think about some of these things. And maybe some of it is also, again, there is a difference between a medicament with severe side effects and then some food where you want to control for contaminants and for that it goes bad, but it's slightly different if there aren't really normally side effects and you can control for that in an easier way. So I think we need to be more nuanced in these kind of discussions. That's my take. This was a very long answer.
It's a good one. Thanks.
Are there more online, or should we take one from the room? I think we're good. Anyone in the room wants to throw in a question in the mix? You have one? Of course you can.
I'd like to ask, when you were analyzing biases, how was it that you did it? Was it easy to analyze the biases, or?
Okay, I did it from some of the existing fairness metrics. So I think in the last one I show is demographic parity. So it's basically kind of, do you have an equal prediction accuracy for different demographies? So you don't want to be doing very well for one demography and really poorly for another demography. But there are different fairness metrics according to what you want to figure out. And then there is some of the new research where if your labels are inaccurate, you can actually make it worse if you calibrate towards these. So in the first sense, I haven't really done anything to calibrate but just investigate the models to understand. And my go-to would be, okay, a little bit engineering-y, saying, okay, if I want to fix that or try to do the best I can, maybe I want to look at the input data and say, okay, have I actually covered this demography in a good way? But there could be in labels, like for instance, emotions. Who is labeling that? Maybe we, in different cultures, perceive and express emotions in different ways. So it actually kind of makes sense, and that it's difficult to build one model that works for everything. And startup-wise, I really think in cultures, because it's language and it's a lot of this. So yeah, looking at markets and having to redevelop actually for new cultures, because otherwise I think you might do something that, just won't work. Yeah.
Yeah, that's a really good point about different cultures have emotions show up in different ways.
Yeah.
There is one more question here. We do have time for that.
Yeah. Hi. Really interesting with the different cultures. I was just wondering what kind of scale of data would you need to make a specific model for a culture which has very specific kind of, I guess, patterns and reactions and ways to show emotion?
It depends on the model that you're building, and some of what we're doing for the low resource modeling is also transferring and also looking at what we did for some of the speech emotion recognition was to say, okay, maybe emotions are not very transferable, but some labels like activation and label, which is like a two-dimensional space of emotionality where you could actually project all of those emotions into, but they would just lie different for different cultures. But how activated or sort of positive versus negative your voices, that's actually something that we could do a little bit more objectively. And so that would transfer a lot better across cultures, but then we could have this mapping in different ways. And then you might need a lot less data to understand that. Mm-hmm.
Thank you so much, Lena. I think it's time for the shift. Thank you for good questions.